Let's take a look at how to write some more examples, some more chemical reactions from words. Magnesium metal. I know that I have magnesium and it's metal, so it's not mixed with anything else. It's in the solid form, therefore. Reacts with oxygen gas. Oxygen gas, I know that it's in a diatomic form, meaning there's two oxygens in oxygen gas, not just O. And it produces solid magnesium oxide. Magnesium oxide, and that's a solid. Now this is an ionic compound, so I have to make sure that it is balanced. Oxygen is a group 6 element, which means that it has a 2- charge all the time. Magnesium is a group 2 ion, which means that it has a 2+ charge all the time. Therefore, my charges cancel out, give me a neutral compound. I don't have to worry about it. Now, as I look to the whole equation, I have to figure out whether it's balanced or not. It's not balanced because I have 2 oxygens over here and only 1 over here. To balance it out, I can put a 2 in front of the whole molecule. That gives me 2 oxygens, but I have 2 magnesiums on this side now. To make this the same, I can put a 2 in front of that magnesium, and it makes it equal. Remember, we change coefficients in front of molecules when we balance the whole chemical reactions. When we're looking to neutralize, to write a neutral formula for an ionic compound, we mess with the subscripts. Let's take a look at example number 2. Sulfur dioxide gas. I know that I have sulfur, and I have oxygen, oxide. Di, the prefix di, tells me that there's 2 oxygens, and it's in the gaseous form. It reacts with water vapor. We know the formula for water, H2O. Now it says it's vapor, which means it's in the gaseous form as well. It reacts to give me aqueous hydrogen sulfite. Once again, make sure you learn the polyatomic ions. Sulfite is SO3, and this is an aqueous solution. SO3 has a 2- charge. Hydrogen has a +1 charge. Therefore, I have to make this a neutral compound. How do I do that? Well, I need to increase my positive charge to make it a 2+, and I do that. Do not put it in front because that is only to balance the whole chemical reaction. Remember, we are writing neutral compounds, which means we do mess with the subscripts now. I need 2 hydrogens to give me a +2, and I can do that by putting a subscript by the hydrogen. And now I have a neutral compound. Let's take a look at the whole equation to see if we have a balanced chemical equation or not. I have 1 sulfur, 1 sulfur. I have 2 hydrogens, 2 hydrogens. I have 3 oxygens. I have 2 + 1, 3 oxygens. This equation is already balanced. Let's look at example number 3. I have solid calcium carbonate. Calcium carbonate. Remember that carbonate is a polyatomic ion, and it's a solid. The calcium carbonate is. Carbonate is a 2- charge. Calcium is a 2+ charge. This, as it is written, it's already neutral. I don't need to change anything. I don't need to manipulate the subscripts. Solid calcium carbonate reacts to form, so it breaks down and forms solid calcium oxide, and that's a solid, and carbon dioxide gas, CO2. Carbon oxide tells me it's an oxygen. The di in front of dioxide tells me that there's 2 oxygens, and that's in the gaseous form. Okay, I have to make sure here that I have a neutral compound because it's a metal and a nonmetal, so it's an ionic compound. Oxygen is a group 6 element. It will always have a 2- charge. Calcium is a group 2. It will always have a 2+. This is also balanced. I don't need to mess with anything else, any other compounds. Now I need to look at the total reaction and figure out whether I have a balanced chemical equation. I have 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygens, 1 oxygen plus 2 over here makes 3, and I am balanced already. I don't need to put any other coefficients. Let's take a look at number 4. I have potassium chlorate. Once again, learn your polyatomic ions. Chlorate is ClO3 and it has a -1 charge. Okay, that is a solid. It reacts to form potassium chloride, KCl chloride, and oxygen gas. That's a solid. And oxygen, remember, it's a diatomic 2, di meaning 2 atom, diatomic molecule, along with chlorine, so chlorine gas, fluorine gas, iodine, bromine, they all have O2, Cl2, F2, Br2, I2, etc., etc. So they appear with a 2, not just by themselves. Now let's take a look at the ionic compounds and make sure that I am balanced, or I have neutral compounds. ClO3, the whole unit here has a -1 charge. Potassium is a group 1 element, a group 1 atom, so metal, so it will have always a +1 charge. The way this molecule is written is neutral. I have a +1 and a -1 charge, I'm balanced. What about here? We said that chlorine is a group 7 element. It will always form a -1 ion. Potassium is a group 1. It will always form a +1. That is a neutral compound as well. Now let's take a look at the whole reaction and see if I am balanced. I have one potassium, 1 chlorine, 1 chlorine, but I have 3 oxygens and only 2 over here. Let's make the odd number even. Let's put a 2 in front of that the potassium chlorate. Now I have 2 potassiums and 2 chlorines, but only 1 of each here. If I put a 2 in front of the whole molecule here, I make 2 potassiums and 2 chlorines. So I'm good there. Now, how many oxygens do I have? I have 2 times 3, 6 oxygens on this side, but only 2 on the right side. To make this a 6, I can put a 3 in front of that oxygen and make this 6. 2 times 3 is 6, and I'm balanced. Okay, let's take a look at example number 5. Magnesium metal reacts with aqueous hydrochloric acid. I have magnesium metal, that's a solid. It reacts with aqueous hydrochloric acid, HCl, hydrochloric acid, and it's aqueous, to give me aqueous magnesium chloride and hydrogen gas. Magnesium chloride aqueous. Oops, so let's just write it this way first. Plus hydrogen gas, H2. Hydrogen is another one of those diatomic molecules, just like oxygen. It will actually be in its natural form. It will be as H2. Let's take a look. I have magnesium, but then I have HCl, which is, in this case, will be an ionic compound. So I have a -1 on the chlorine, -1 charge. Hydrogen is a +1, so that means this is a neutral compound. Now when I go over here, I know that chlorine is a group 7, so we'll always have a -1 charge, but magnesium is a group 2, which means that it will have a 2+ charge. Therefore, the way it's written, this compound is not neutral. I need to increase my negative charge to make it equal to 2. And I don't put the 2, once again, we haven't really started balancing the chemical reaction. I'm looking at the compound to make it neutral. To do that, I do use the subscripts. To make this neutral, I need 2 negative charges. Therefore, I need 2 chlorines. That makes 2 times -1 a -2, a +2 a 0. Now that I have written a neutral compound over here, I can take a look at the whole reaction and make sure that I'm balanced. I have 1 magnesium, 1 magnesium. I have 2 chlorines and 2 hydrogens, but only 1 of each. Therefore, if I put a 2 in front of that HCl, now I've balanced both my hydrogens and my chlorine, and I am balanced. Let's take a look at the last problem. I have aqueous copper 2 sulfate. Remember that we said in a previous example, the Roman numeral tells us the charge on the metal because it's a transition metal and it will form multiple ions. Therefore, the copper 2 tells me that copper has a 2+ charge in this case. And I have a sulfate anion. Sulfate anion is SO4 and it has a 2- charge. Therefore, the way it's written, it is a neutral compound. 2 - 2+. I don't need to mess with subscripts. And it tells me it's an aqueous solution. It reacts with magnesium metal. Magnesium metal, anytime you read metal, that will mean magnesium by itself in the solid form. All metals are solids in their neutral as just elements by themselves, except for mercury. And it produces, so these two react and produce copper metal. Once again, copper metal, solid form by itself, and aqueous magnesium sulfate. Magnesium sulfate, SO4, and it's aqueous. Now let's take a look and see if this is a neutral compound. We said SO4 has a total negative charge of 2-. This is why you have to learn the polyatomic ion names and the charges on each of them, the formulas as well. Now we know that magnesium is a group 2+, or a group 2 ion, group 2 metal, I'm sorry, so it will always form a 2+ ion. Therefore, because I have a 2+ here and a 2- here, this is a neutral compound the way it's written. I don't need to mess with the subscript anymore. Now I have to look at my total reaction and see if I'm balanced. I have 1 copper, 1 copper, 1 magnesium, 1 magnesium, 1 sulfate group, 1 sulfate group, and I'm already balanced. I don't need to mess with the coefficients in front of these molecules or elements. This is how you go about writing neutral compounds and balancing chemical reactions when you have words and you are translating them, transcribing them into actual chemical formulas.